Homework 12, Polynomial Division, Factor Theorem, Rational Zero Theorem, Video 6. In the previous video, I kind of hinted about how a zero of a function and a factor go hand in hand. Here's how we can take advantage of that. For example, let's find all the zeros of the function f of x equals x to the third power minus 7x squared plus 5x plus 21 if f of 3 is equal to 0. So in other words, I just gave you a zero of the function. 3 is a solution to this is equal to 0. So how can we take advantage of that? Well, by connecting some observations. Since f of 3 equals 0, then x equals 3 is a zero of f of x. That's the definition of being a zero. I'm the number that makes this function equal to 0. By the factor theorem, x minus 3 is a factor of f of x. And remember the main reason why. Because if we were solving something, the last move would have given us x equals 3. But the previous move would have had that equal to 0. So it had to be x minus 3 that got us there. That's the reasoning behind it. Observation number 2. Since x minus 3 is a factor of f of x, then the answer to f of x divided by x minus 3 is the other factor. Or I should say is I'm gonna bring in a new word, is the cofactor with x minus 3. And what I mean by cofactor is two factors together that make a product. For example, if I said 4 is the cofactor of 5, then the product is 20. Because what number do you multiply by 20 to get, what number do you multiply by 4 to get 20? 5. So anytime you have a factor pair or a multiplication problem like 3 times 17 is equal to 51, you would say that 3 and 11 are cofactors of each other in this product. They are the two factors that make the correct product. So if we know one factor of a polynomial, we can divide to find the other factor. In other words, its cofactor. So let's take advantage of that. Let's do this division problem. Let's divide the function, which is x to the third minus 7x squared plus 5x plus 21 by x minus 3. And we can do that with a synthetic division problem. What number would go in the box? The opposite of the number in the divisor. Wasn't 3 the original number we started with? It is. It goes through an identity crisis. I'm positive. I'm negative. I'm positive again. But as long as you stay focused, you'll know when it changes signs. The top row is just the coefficients of the dividend. So 1, negative 7, 5, and 21. I invite you to complete the synthetic division really quickly. Maybe pause the video, because I am going to go through it quickly. Starting by adding the first column. Add to get 1 times the box. 1 times 3 is 3. Add the next column to get negative 4 times the box is negative 12. Add the next column to get negative 7. Multiply by the box to get negative 21. And add the last column to get 0, but I'm not surprised. I knew it was a factor. It had to divide evenly. Its remainder had to be 0. So, what does this bottom row translate to as a polynomial? Reduce the degree by 1. So instead of starting with x to the third, it will start with x to the second. 1x to the second minus 4x minus 7 is the other factor. So, if we're going to find the zeros of this function, you set it equal to 0. That's how you find the zeros of a function. 7x to the third power, x to the third power minus 7x to the second power plus 5x plus 21 is equal to 0. And I know two factors. One is x minus 3. Thank you, factor theorem. The other is x squared minus 4x minus 7. Thank you, synthetic division. Now I can finish solving. I already know what this first factor will give me. It will give me the 0 I was given at the beginning. But what will the other one give me? Well, it's a quadratic equation, and we have ways of making it give up its solutions. I'm going to fast forward and just say if we use the quadratic formula, we'll get x equals negative b, so 4, plus or minus, I'll come back to the square root in a minute, over 2a, so over 2, I'd have to do some reducing, square root of b squared, so negative 4 squared is 16, minus 4 times a times c. 4 times 1 times negative 7 is negative 28. So minus negative 28 is positive 28. So we get 4 plus or minus the square root of, looks like it's going to be 44. Yes? Yes. Oh, that's just screaming to be reduced. I can split 44 into 4 times 11. So the square root of 4 times the square root of 11. Let's move the answer up here. So 4 plus or minus the square root of 4 is 2. Don't know the square root of 11. This is still all over 4. There are ways to approach reducing this. One way is to split it into 2 fractions, 4 over 2 plus or minus 2 square root of 11 over 2. And then each fraction reduces separately. 2 plus or minus square root of 11. So now I know the answer to my question. The question was find all zeros. Well, I was given one of them. So 1 0 is 3. One of them is 2 plus the square root of 11. And one of them is 2 minus the square root of 11. Small amendment, and this will be reflected in the title of the videos. I'm going to remove the rational zero theorem discussion from this video and in this series of videos here. But keep in mind that as you go through homework 12, when you get to the questions that ask you about the rational zero theorem, and you'll know them the minute you see them, then you'll need to allude to the next. Actually, you know what? I'm going to go on the homework and take out the rational zero theorem questions and put them in their own homework problem. So this brings to conclusion homework 12. It takes a little getting used to, but I promise you it's pretty straightforward. If you have any questions, let me know.